Good day. We're still working on nomenclature of alkanes here. And if you were in 332, you just got an extensive workout on we give you a picture and you tell us what the name is. The flip side of that is if we give you a name, you should be able to draw its picture. So we want you to be able to go in both directions. So when you're drawing these, I respectfully suggest that you start on the right hand side. Because you remember when we're giving these names, we talk about all the branches first. And only at the end do we finally tell you what the primary is. So big complicated names like this that have branches and branches and branches and branches and finally the primary is kind of like saying a hat and mittens and a scarf on an elephant. If you had to draw that, you'd probably start by drawing the elephant, at least I would, and then after that you can worry about, okay, now we put a hat and a mittens and all the little details on it. But the most important word in these names is generally the very last word because that tells you the frame you're going to attach everything else to. So, when you see something like this, you as blah 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 heptane. A heptane is 7 carbons in a chain. C, 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 5, 6, 7. You can do them in a straight line. It's arguably better to do them in a bit of a zigzag like this. So, there's 7 carbons. This is heptane already. I know there are hydrogens, and I'll take care of them shortly, but let's just get our structure together first. Now this says, on the 3rd carbon, put a methyl group. Done. If you were in a big hurry, you could give this as your structure, and people would say, okay, they left the hydrogens off, and that's not great, but at least they understand the shape. To take care of the hydrogens, remember, a carbon is an atom with 4 arms, so to speak. Its Lewis structure looks like this, which means carbon is capable of holding on to 4 things at any given time. So when you look at a carbon, you're expecting 4 lines coming off it. In this case, I only see 1, and that means the other 3 arms that this carbon has must be holding hydrogen. This must be a CH3. When you get to this carbon, there are 2 arms coming off it, so it has 2 more arms that could be holding hydrogen. This carbon has 3 arms coming off it, so it's only got room for 1 hydrogen. This carbon only has 1 arm coming off it, so it can hold 3. 2 bonds, so 2 more left for hydrogen. 2 again. 2 again. And this carbon only has 1 line coming off it, so it can hold 3 hydrogens. Okay? If you look at that, every single carbon has 4 connections to it, either a line or a hydrogen, so that all 4 of its arms are committed. That's what's supposed to happen. Let's do a few more. Blah, 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 pentane. Pent means 5, 2, 3, 4, 5. Okay. Okay, there's your basic pentane. There's 5 carbons. They're bonded together so they won't go floating off into the ether. And now this says on the 2nd carbon and the 3rd carbon, put methyl groups. So, carbon there, carbon there. That takes care of our structure. Now we just do hydrogens. This has 3 bonds coming off it, so only room for 1 hydrogen. 3 bonds, only 1 hydrogen. 1 bond, 3 hydrogens. 2 bonds, 2 hydrogens, because the total is always 4, and 1 bond, 3 hydrogens. Not too bad. Let's make it worse. Blah, 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 nonane. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's nonane. On the 4th carbon, put an ethyl group. Hurting for space, but we'll make it work. On the 4th, 6th, and 6th carbons, put methyl groups. Whoa. 4th carbon. I'm sorry, I don't know how I got to there, but that is emphatically not the fourth carbon. Let me sort myself out here. All right, pen tool, white, bigger. All right, there we go. Woo. It is, apparently my brain is checked out a little bit early. Sorry about that. So, fourth carbon. Here we put an ethyl group. Also, on the fourth, sixth, and sixth carbons, put methyl groups. So there's a C, and then that's 5, that's 6. Okay, that's more like it. That's 4-ethyl 4,6,6 trimethylnonane. And now we do it a whole bunch of carbonizing. One bond, so 3. This carbon has 4 bonds coming off it. This cannot hold any hydrogen. All 4 of its arms are already doing stuff. But this one can take 2. This can take 3. This can take 3. 2. This one also has all 4 of its arms in use, so there's no room for hydrogen on there. But that's a CH3. That's a CH3. You've probably noticed when you have a long chain with no side branches, you get a long string of CH2s. That's kind of the normal middle of the chain piece. On the ends, you always have CH3s. And at 4-way intersections, you tend to get a C that can't hold anything else. That's not an accident. That's what happens when you put more connections on a carbon. It loses. It's giving up hydrogens to hold these other things. 2,2,3,3 tetramethyl 4-propylheptane. Okay. All I heard there was heptane. 1, 2, 3, 4, 5, 6, 7. Okay. 4 methyl groups on carbons 2. So we're going to go C and C. You could put these both up like antennas or bunny ears if you wanted, or you can go up down like this. Later in organic chemistry, we'll get very precise about the molecular shapes, but we aren't there yet. So for now, enjoy how relaxed it is. Here's your propyl group on carbon number 4, and nothing on the other groups. For all of these, by the way, I'm numbering from the left, because if you get to draw the picture and you get to decide where the numbering is, why not go left to right? That's the way that you read, or it's the way I read in the languages I know, so make it easy on yourself. Could you go from right to left? Absolutely, but you're going to make life a little bit weird for Anglophones who read your stuff. So only do that if you want to mess with them a little. Hydrogens. All these peripheral ones are going to be CH3s. That's a 4-way, so there's nothing there. Also a 4-way, no room for anything there. This is a 3-way intersection, so there's 1 hydrogen space left there. This will be CH2, CH2, CH3. And then this is CH2, CH2, CH3. Whenever there aren't side branches, that's your pattern. Bunch of 2s in the middle and then a 3 on the end. Good? And finally, 2,2-dimethylpropane. Propane is 3 carbons. 1, 2, 3. Methyl groups on the second carbon. So, okay, this thing's kind of star-shaped or plus-shaped. Or pyramid-shaped. And, yeah, that's the entire structure. It's a propane with 2 methyl groups on it. And now we're right into hydrogen. No room for any hydrogen in the middle, and all these things around the outside are going to be CH3s. Quick note. Sometimes you will see this. If a carbon is off on the left, the way it would actually be arranged if you get down to the level of single atoms is it would look like this. You'd have the carbon sticking out and then 3 hydrogens around it like so. If you write this as CH3, that is fine. Sometimes they will write H3C, recognizing the fact that the hydrogens are to the left of the carbon, and so it's a little bit more correct to say the H's first and then the C, because the hydrogens really are further off in this direction. That's kind of a fine detail, but if you see this, don't let it worry you. This and CH3 mean exactly the same thing. They're just trying to make the drawing reflect the realities of the molecule a little bit better. If you want to do this, you're welcome to. We don't mind. You'll see both during your chemistry life, and I've never seen anyone have a problem with it, but I don't want it to mess you up when you see it for the first time. Good. Catch you on the next page.